Hello, I'm Lara Rodrigues, a PhD student in astronomy education at the Pontifical Catholic University of Chile. My talk is about the interdisciplinary links between the school curriculum and the big ideas in astronomy, with a case study in Chile. As you know, this workshop's main purpose is to discuss what everyone should know about astronomy education. Well, I believe it's important to know that the big ideas in astronomy can framework interdisciplinary links within the school curriculum to promote astronomy literacy. The Big Ideas in Astronomy is a booklet with a proposed definition of astronomy literacy, released in 2019. I propose that it can be used to relate other science topics in the curriculum to up-to-date astronomical ideas, and thus direct the curriculum towards the development of astronomy literacy. And I say that based on the results I got from my case study of the science school curriculum in Chile, and also from work in developing two astronomy interdisciplinary units focusing on big ideas. So let's talk about that now. Starting with the context and motivation for my work. The first one is the importance of astronomy as a vector for science education. Astronomy is well known to awaken children's curiosity for science, motivate students towards scientific topics, and develop abstract thought. However, astronomy has a small presence within the school curriculum worldwide, and it's mainly in a descriptive level and restricted to Earth, Sun, and Moon topics. In fact, a recent study by Salimpur and collaborators found that all OECD countries include astronomical topics in their school curriculum, but they are mostly based in facts rather than concepts and show a lack of progression in many countries, being present only in a few grades. And as for the local context, Chile is home of the world's largest telescopes, but less than a third of people declare having some astronomical knowledge. So the last curricular reform increased the number of astronomical topics in the Chilean science curriculum, seeking to improve astronomy and science education, but this new curriculum was not studied in detail yet. So, in this context, I proposed a study to characterize the opportunities to learn astronomy within the Chilean science curriculum from grades 1 to 12. The corpus of this study was comprised by all Chilean curricular documents from grades 1 to 12, and I took only the science sections of each document. So I processed this data in 3 steps. The first one was to segment the learning objectives, which are the statements that describe the knowledge students should acquire. These are very extensive in the Chilean curriculum, so I have segmented them into micro-objectives to clearly identify the contents and cognitive processes they promote. So with this segmentation, each micro-objective includes only one cognitive process and only one content. Then, the next step was to classify these micro-objectives into directly, indirectly, and not related to astronomy. According to this criteria, the micro-objectives that refer explicitly and exclusively to space phenomena are classified as directly related to astronomy. The micro-objectives that refer explicitly but not exclusively to space phenomena, or those micro-objectives that do not refer explicitly to space phenomena but are connected to the big ideas in astronomy, are classified as indirectly related to astronomy. And finally, the micro-objectives that do not refer explicitly to space and cannot be connected to the big ideas are classified as not related to astronomy. And the last step in data processing was to codify every micro-objective directly or indirectly related to astronomy in 3 dimensions: cognitive processes, astronomy subject, and big ideas in astronomy. In this talk, I will focus only on the big ideas classification. So the main results I got here were first that only 80% of the Chilean science curriculum micro-objectives are directly related to astronomy, and 14% are indirectly related. So less than 25% of the Chilean science curriculum can be related to astronomy somehow. And when we look at it all over the grades, we can see that the micro-objectives directly related to astronomy, in blue, are present only in grades 1, 3, 9, and 10, and with a small presence in the elective courses of grades 11 and 12. But when we look at the micro-objectives indirectly related to astronomy, in orange, we have opportunities to learn astronomy present in all grades. And regarding the classification in terms of the big ideas in astronomy, we can see here that the micro-objectives directly related to astronomy are present in 8 of the 11 big ideas, with predominance of ideas 2, which refer to astronomy in day-to-day experience, and idea 7, which is about the solar system. The micro-objectives indirectly related to astronomy are distributed in 9 of the 11 big ideas, covering those absent in the directly related ones, and with a predominance of idea 10, which is, say, we may not be alone in the universe, and idea 5, which is about technology. And when looking at the whole graphic, we can see that all big ideas could be covered by the Chilean science curriculum, but with less opportunities for ideas 1, 3, 6, and 9. However, it's important to notice that when doing this analysis, I realized that classifying each micro-objective in only one category is not enough, especially in the indirectly related ones, which contain many interdisciplinary links. So I'm currently expanding this analysis to consider more than one big idea per micro-objective, so these numbers will increase. So the main conclusions of this study are the following. First, we saw that the micro-objectives directly related to astronomy occupy only a small portion of the curriculum, representing a low percentage of the learning objectives, covering only a third of the school grades, with a small variety of astronomical topics, and also with low cognition levels. On the other side, the micro-objectives indirectly related to astronomy appear in all grades, include more topics and higher cognitive processes. So when we consider these micro-objectives, we can increase the opportunities to learn astronomy within the Chilean science curriculum. And the big ideas in astronomy could be covered by these micro-objectives, especially considering the interdisciplinary links. In this sense, it seems that the astronomy potential for science education is not well explored in the Chilean science curriculum, but there are opportunities to address astronomy through interdisciplinary topics like astrobiology, technology, climate changing, and others. So, the teaching of astronomical topics through micro-objectives indirectly related to astronomy is a way to improve astronomy literacy in school education. But it's also challenging because a teacher needs a more profound knowledge in astronomy in order to notice these opportunities. So we should provide them with knowledge and resources for this to work. So let's see some practical examples developing two interdisciplinary astronomy classroom units focusing on the big ideas. The first one was focused on idea 10, which say we may not be alone in the universe. It was developed especially for the Chilean Summit of Astronomy Education and Outreach in 2019, as a joint work with researchers from science education and last year pre-service school teachers. We worked only in science, with physics, chemistry, and biology in secondary education, and also with primary education natural science. So during 3 months, we studied the curriculum, selected the appropriated grades and learning objectives, and then developed together 2 parallel units for both 3rd grade and 9th grade, with the same guiding question, which was, how can we know if there is life in a planet? So the unit started with a motivation activity with a piece of news, which was about the TRAPPIST-1 system. Then, for 4th grade, there was an astro game to determine the conditions of life. And for 9th grade, there was 3 activities, 1 for each discipline. And it ended with a closing activity to answer the initial question with the evidence collected during the other activities. We presented this unit to the teachers participated in the summit and tested some activities with real students at school. But we were not able to apply it fully with an interdisciplinary group of teachers at the same school due to the pandemics. But the unit is ready to be applied when the conditions allow it. And the second interdisciplinary unit focuses on idea 7, which says we are all made of stardust. In this unit, we were 3 science education researchers and 5 secondary school in-service teachers. The development of this unit was part of a professional development program funded by OAE and IAU. It was a 6-month work with virtual meetings almost every week. We worked with 3 disciplines, physics, biology, and ARS. And as in the other units, we studied the curriculum and the big ideas to choose the grade and the curricular learning objectives to work with. We also used a guiding question, which was, what is the meaning of we are all stardust? The final unit is planned for 9 classroom hours, include game development and an artistic installation. I cannot show you the details because it's still copyright protected, but if everything goes well, the teachers will apply this unit at the school in this semester, and then it will be publicly available. And now to end this presentation, let's see some discussion points. As we saw in the results of my curriculum study, the big ideas in astronomy can framework interdisciplinary links within the school curriculum to promote astronomy literacy. And a good practical application is the development of classroom units. But it requires a joint work with an interdisciplinary team with astronomers, education specialists, teachers, etc., so it's not a simple task. Then we, the astronomy education community, must provide resources. We can make an international effort and develop local initiatives connected to each country curriculum. I believe that we can detail the interdisciplinary relations between the school curricula and the big ideas and create handbooks for teacher training and professional development programs, so we can apply these results in classroom. And that's one of my plans for the future, so I invite whoever wants to collaborate with me. Thank you.